Hi, everybody, and welcome to our expert Q&A session on IoT and data. We are your hosts for today. I'm Adi Polak, and I'm your host for today. And I have with me my colleague, Christopher Manu, which is a startup club advocate focused on IoT. And also, fun fact, he's a scuba diving instructor. Hi, Christopher.
Hi, Adi. Hi, everyone. Welcome to this expert Q&A. And let me introduce you to my colleague, Adi. Adi is doing open source engineering, and she is specialized in big data workloads. You?
All right, so this is our agenda for today. We're going to go over what to expect from the session, and then we're going to open it up for you for questions and answer, and we're going to finish with fun slides that you can later on continue and learn about IoT and data.
So there is a few ways to engage with us. Please use the chat box, on the right side of your screen to ask some question. We already have a few questions here. You can post anonymously or use your name as you prefer, and a question will appear to every attendees once we approve them. If one of the question seems quite interesting for you, you can upvote any question, and we will start to answer the most upvote question first.
Please remember, this session will be recorded, so please don't record the session. Try to help our moderators. Don't spam the chat. If you see someone already asked a question, just upvote it. And please adhere to the Microsoft Code of Conduct.
Just a quick note about the Microsoft Code of Conduct. You should have seen this when you register for this event. We try to create inclusive events, so we ask you to please adhere to the Code of Conduct. Few words about us, and there is already a few bunch of questions. So it's just some info about the kind of question you can ask to us. We try to answer what we can during the next 25 minutes. So Adi, we already have a bunch of questions. Maybe we will start with, let's say, so there is one question. Without using Azure Stream Analytics service, what is the best way to route IoT hub data to hot and cold storage? Maybe this question is for me, but Adi, do you want to introduce briefly what is Azure Stream Analytics for people who don't know about it yet?
Sure. So Azure Stream Analytics basically help us build a pipeline for analytics on data. So we can, from the UI, from the portal, or using the CLI, can combine a bunch of pieces of input and output to work together, as well as adding some logic on it using SQL. So it's really fun. You can take data from event hubs and mix it and add some stuff and store it in storage or other output that you want to serve it at. So it's a really cool platform. It works extremely well. Some of the most common use cases is combining it with event hubs. If you work in the big data area like me, you might know of a file format named Parquet. So let's say you want to take your stuff and all your input and save it to Parquet. So one of the known use cases is basically streaming from event hubs to analytics stream and save those files in Parquet format so you can later on do big data analytics on it.
Great, Adi. And to answer the question, what's the best way to route all this data if you don't have, if you cannot use for any reason Azure Stream Analytics? To hot and cold storage, first you need to be aware that within Azure IoT there is some features that allows you to, for example, dump all messages into a storage account. So that could be one way to actually output all information into cold storage. For the hot storage part, one of the things you can do is to maybe put an event hubs between your IoT hub and maybe some Azure functions, and then having this Azure function write to your hot storage, whatever that kind of hot storage you can have. So next question, we have a question from Raphael about IoT, talking about a scenario where basically they have a bunch of different sensors and drives in a factory, but this factory, for reason we can definitely understood, is not connected to internet. So how can we still use Microsoft Azure technologies and products while having this disconnected scenario? Actually, this is a very interesting scenario, and this is one of the scenarios we have all over when we talk about IoT. Maybe you have no internet connection, or maybe you have very, very limited IoT connectivity. So there is different ways to use Azure products to solve these issues. One of them could be to use an Azure Edge gateway. So basically you can install a gateway within the factory boundaries that we talk to all your devices, and we kind of act as a disconnected proxy, and then you will be able to take data from this specific edge device and connect this specific edge device from time to time to Azure IoT. So this is one of the scenarios where, for example, you have some IoT devices who do not have an internet connection or TCP connection. That's the kind of architecture we use to be able to connect these devices. One other solution you can look at is all the services we do about Azure Edge and Azure Stack, which are basically a range of products that allows you to run part of the Azure services within your own data center or within your own environment, and they can be as well connected to Azure IoT when you want it. So there is different scenarios to explore to answer this. So I will go over to the question we didn't triage first. And
so,
yeah.
Christopher, I just published a great question by Pete. Maybe you can take a look at that. He asked about IoT Central.
Yeah. So Pete question, my client wants to be able to query his data using SQL. So I looked at the event hub that I export to an Azure function, to Azure SQL Server, and out to an Azure Web Apps. There is not going to be a huge amount of data, but still dozens of sensors and messages twice a minute. Is this the best / most cost-effective way to do this? A great question from Pete about connecting different services and getting the data out of the IoT products onto other products and to the hands of the users, the final users. There is different ways to do it. To answer your question, we need to explore exactly the amount of data you're trying to import into your Azure SQL database, and also if you're already using the SQL database for another usage, another part of your application, for example, and the type of queries you will try to run over this set of data. It seems like it could be a good architecture choice, even in a cost access. One of the other options you may have is to, depending on what kind of data or how you're querying your data, could be to explore Azure Cosmos DB. We just announced auto-scale and a free tier for Azure Cosmos DB, though. So maybe you'll be able to, if you are only having a handful of sensor, setting a very few data, totally run on the free tier of Azure Cosmos DB. Another idea, if you are querying in a very time-sensitive way, would be to use time series insights product. and this probably could be quite cheap if you're trying to do time-sensitive data. And maybe ID, you want to add something to this answer?
I think you covered it all, actually.
Great. I just saw a question about ADLS and ARVO format and exporting to Power BI. So maybe you want to take a look at this one. I've just published it.
Oh, cool. So using ADLS Generate 1 with cold storage and routing it to event hubs as endpoint to capture the data and store in ARVO file format. Well, it depends. So good question. The question is, I already have data in a cold storage and I want to change the file format. How do I do that? So it really depends on the size of the data. So if you have a lot of data, you might want to look into a managed Apache Spark like Azure Databricks, because it allows you to get in a bunch of data, like giga or terabytes of data, create a job that transfers the data from ARVO file format to your text, CSV, and TSV file format desired, and then save it back into IDSL Gen 2 or Gen 1 or Gen 2 or any other cold storage that you would like. So you will need some pipeline in the middle to switch the file format. You can do it with Azure Databricks or Azure Data Factory as well. You can write a job that does that.
Great. I saw a question from Zanoni about deploying devices in area with very poor connectivity. For example, Zanoni explained that it defaults to Wi-Fi, but definitely because Wi-Fi is maybe not reliable, I need to add mobile SIM cards, which is expensive, and it is right. Having IoT devices, and actually I have one IoT board just here with a SIM card in it, and it got a few euros per month to have it. So if you're deploying hundreds of devices, it's definitely not the solution. What you can do to compensate that is again using the pattern of having a gateway. So placing somewhere a gateway. And it will be the only way to have an Ethernet connectivity. The gateway will be the only component to having an Ethernet connectivity, and all your sensor and devices will connect to a low-range wireless network. For example, one of the best known here is LoRa, L-O-R-A, and you can actually deploy LoRa gateways and LoRa devices. So basically, between all your devices and a central point. So let's say you have a huge farm field or you have a huge building, etc. You can deploy only one gateway to cover all this area. And devices will connect to the gateway through LoRa and LoRaWAN, and then this gateway will be the only component to connect to the internet. And this component can also buffer data if you have a like few minutes where you don't have a very good connection. This gateway can buffer the data, so when the connection is up again, then the data could be sent to Azure IoT. So that's one way to do it in a poor internet, public internet availability areas. I don't know if you have another question, Adi. I spot one.
Yeah, so we have a bunch of really good questions. Please help us with upvoting so we'll know which one you want to hear first.
Yeah. So we have a question about built-in machine learning models in stream analytics. I don't know if you see it.
Yeah. I saw, I think I saw it. Cool. All right, so I'm not familiar with direct machine learning in stream analytics, but what you can do is we have Azure Machine Learning workspace. So you can save the data from stream analytics and then load it as a data set in Azure Machine Learning workspace. And from there, you can leverage a lot of great features like AutoML. And with AutoML, you just pick the family of algorithms in machine learning that you wanna run. Let's say you wanna run regression or you wanna run classifications algorithms and so on. And then you pick what kind of output are you expecting? Are you expecting a classification on a specific field? Are you expecting regression and to kind of figure out what's going to be a numerical value or predict a numerical value? And basically, it's all you can run it in a matter of just you click it and then it runs and it runs a lot of different machine learning algorithms for you. It gives you the accuracy. It gives you something called ROC curve from the machine learning area, that it's another way to measure your algorithm. And then you can pick which one you want to continue working with and actually deploy it later on into your IoT device. Because what it does, it creates a Docker for you. So you can basically take that Docker and deploy it everywhere you want. So if you want to run Kubernetes or you want to deploy it on your IoT device or anything like that, which is really cool. Or if you want to keep it in the cloud and use it there. So you have AKS or ACI, Azure Container Instances, that you can leverage. Yeah, pretty cool. I put the links into the chat into how you can work with Azure ML services.
Great. And so please continue to upvote if you have any question you prefer we answer first. We still have about 10 minutes to answer your questions. We have an IoT question from an anonymous attendee. He sent telemetry data to IoT Hub and this user in the system needs to have the latest state of the devices in a UI. And also once in a while get all the data for maybe the last 3 months or the last 3 years, because one of the requirements of these customers is to have the data saved like forever, no retention period at all. So the user can download all the historical data. No analytics needed on this data, and the question is, what do you recommend in our use case and why data lake time servers? And also there is a few transportation transformation requirements planned, and they plan to use stream analytics. So what I think about this, definitely, if you want to save so much data, and for a very long period of time, I would direct you to the blob storage. And definitely as a blob storage. Why? Because first, as you say, you don't really need to do any analytics on top of this data. And even if you wanted to do it, we have ways to tap into data stored into blob storage. Secondly, we have different tiers of data storage: hot, cold, and archive. So, for example, archive, you can pay very less more than a hot storage. So if only you need to download the data once in a while, it may take a few hours to get your data back, but you would pay, I don't know, 1/10 of the price every month. And about the requirement to show the latest state in your UI, what I would recommend you to do is to maybe use the twin feature of IoT Hub, but it will require maybe some changes on your device code. So if you can be able to do this, definitely do it. And within your UI, you can just query the IoT Hub for the latest twin states and show up in your UI. If you cannot do it, one of the things you can actually do it is by using Azure Functions and using what we call the durable actor system that allows you to cheaply persist the state and process the state from IoT data. I've actually written an article about this. I will paste it in a few minutes in the chat window. And maybe, Adi, you want to answer the second part of the question? As they plan to use Stream Analytics for transportation and transformation, what do you think about it? And maybe what are the solutions to if you have to run some analytics on top of data stored in the blob storage, what are our options?
Yeah, so we basically blob storage, it's the most basic storage we have on Azure. So we can connect it and call it and use it from almost any environment on Azure that we want. So if we want to do analytics, there's a lot of cool ways to do analytics. The question is, what's the size of the data and what kind of type of analytics we want to do? Because the reason I'm asking is because one of the most challenging things to do is basically on big data are joint queries. Joint queries are considered to be high compute consuming and very hard. So it might take some time, especially when we work with big data. So we have huge tables we want to run join on. So we need to understand what our logic is. If we're building relatively simple data pipelines like filtering or even simple aggregation, then we can leverage things like Data Factory, Azure Databricks, even a little bit play with event hubs with combination with Stream Analytics. There's some of the options we have, but the real question is how complex my analytics query is if I would to translate it into a SQL query.
Cool. I spot another question from, let me back to it.
Oh, good questions today, huh?
Yeah, from Kunal. I hope from India. I hope I spelled your name correctly. So Kunal is working on a vision analytics solution by using IoT Hub and IoT Edge, and his question is about how we can manage large images and video data upload from the edge to the cloud while managing security, offline network, and maintaining all the data that is uploaded or pending upload. So actually there is a bunch of options, but the first option to look at is within the Azure IoT Hub and Azure IoT Hub SDKs, we have a way to upload files. It's already built in, and the way it works, it's behind the scenes. There is an Azure storage. You can access this Azure storage with the classic APIs. It's not hidden from you. And the Azure IoT Hub will actually manage the upload requests. We'll deliver a SAS key to your IoT device. So your IoT device will only have the right to upload one specific file in one specific place, and not having access to all the container account or all the storage accounts. So it's secure that way, because as soon as the connection between the IoT device and the IoT Hub is secured, only your IoT devices can request a token basically to upload any file. And the cool thing that is already managed by the Azure IoT SDK is that actually your device need to complete the upload, and only when the upload is completed, a message will be pushed into the IoT Hub. So you can have other application that will actually process the message and the file content, but only when it's been successfully uploaded. So it's definitely the first thing to watch out. The other thing I would say that on top of this is beware, and especially about the videos. Videos can be a very, very large files. So you may want to find a way within your application to only upload the relevant videos and not uploading all the videos. So you can use machine learning for this on the edge. You can use a bunch of different things, but just be aware that uploading all the security footage for all the cameras of a building to Azure may not be the best solutions. So Adi, do we have another top advocated question we didn't answer yet? There is a question from Ajit. Again, I hope I spelled your name correctly, about over-the-air updates for IoT, and with a specific question, which is how to do it without interrupting the data transmission on the IoT system itself. Actually, it's a very tricky question. Most of the system on chips, most of the IoT devices actually need to reboot to be able to get a new version, to get an update. So depending on the kind of devices, if you're running onto very low power devices like this one, it could be very difficult, and it's not really a Microsoft issue. It's more a hardware issue. If you're running a more advanced IoT system, like even the Raspberry Pi, and your software is running within Docker containers, then we have some solution, for example, with Kubernetes on the edge. So you may be able to do it, but definitely depending on the kind of hardware you're running to. Oh, and it's almost the time. Adi, do you want to take a last one question?
Let's see. So there is a great question about data quality. So we're trying to deal with sensor data quality issues at source. So our use cases are real-time low latency use cases. How would you deal with data quality issues in stream close to edge? So this is a great question. And again, I'm not sure if it's relevant to Azure, but basically what you would like to do is write a very, very simple script to check your data and decide whether you drop it or you save it. That's it. There are a lot of different ways to validate your data. It highly depends on the data you work with, but there's a lot of list of things you can think about checking, and a lot of things are published on, like a lot of those lists are published online on what you need to check to validate your data. All right.
And we already reached the end of this Q&A. Thank you everybody to have attended this session. We are very sorry not to be able to answer all your questions. We still have at least 20 pending questions. So you have here a few resources if you want to learn more about what we have in Azure, about IoT, and also about data. And you also have ways to connect with Adi and myself. Do not hesitate, at least for me, I don't want to engage Adi in this, but at least
please reach out.
Yeah, please reach out to us on Twitter. For the next few days, we may not be very speedy to answer your questions, but please feel free to contact us. And with that, we wish you a happy evening, happy afternoon, happy morning, depending on your time zone.
Thank you so much for your time.
Bye-bye.